You can also find voltage gain. So voltage gain AVF equal to V naught by Vs. You know V naught is I naught into RL divided by Vs, and I naught by Vs, you know it is GMF. So GMF into RL. So GMF expression, you know, we have derived the expression for GMF. Substitute that, the minus HFE into RL divided by RS plus HIE plus 1 plus HFE into RE. So this is going to be the voltage gain. Now the input resistance. See the input resistance, take the input side, what all resistance you have. I have one resistance RS, I have one resistance HIE, and I have one resistance RE. If you connect an voltage source here, the same current will flow through all the resistance. So when the same current is going to flow through all the resistances are going to be in series. So RI equal to RS plus HIE plus RE. This is without feedback. With feedback, you know RIF equal to RI into D. You should know why we are multiplying by D. It is current series feedback. Input side series. When you see the term series, resistance will increase. So RIF equal to RI into D. So RI, you have expression is derived here, and D, the D sensitivity we have here. So divide both, you get this expression. I told you whenever you have an emitter resistance, this 1 plus HFE into RE term will come everywhere throughout the derivation. This term will ensure that whatever you derived is correct. So 1 plus HFE into RE, if it is coming everywhere in your answer, then it is correct. Because whenever the emitter is not grounded, whenever the emitter is going to have a finite resistance, that will also count for all the parameters in your circuit. So ensure that you are using RE or not in your circuit, and accordingly you have to check your answers, whatever you are getting after the session. So RE is considered to be a part of amplifier. It appears as a part of input resistance. You know that we have split RE across input side and output side, right? So definitely, if you calculate input resistance, RE will be considered. If you calculate output resistance, RE will be considered because it is present as a common component for both input and output. Now the output impedance, you see, I have to remove my load and see what is the resistance. You have only two components, current source and RE. I already told the resistance of current source. Can anybody say what is the resistance of current source? Resistance of current source. What is the resistance of current source? What is the resistance of this current source having value HFE into IB? It is infinity. So infinity plus RE is going to be infinity. So from the figure you have R naught equal to infinity. You have R naught equal to infinity. So the output resistance is going to be, without feedback, it is going to be infinity. If you consider with feedback, it is R naught into 1 plus beta GM. It is also going to be infinity. Okay. So for that reason only, we are going to find one more resistance, what is called as R naught dash. R naught dash is including your RL. So R naught dash equal to, across this RL, you have these two components in series. So infinity plus RE parallel to RL. So R naught dash is going to be RL. Okay, R naught dash is going to be RL, and R naught F dash, I can simplify and get this expression. Okay, so input side and output side, finding the resistance, you should be very, very familiar by now because we have done this for a larger number of circuits. And similarly, you can also find GM from the value of trans conductance, whatever we have given. So in GM, you see it is independent of RL. So when you consider all the resistance to be same, you can see the GM to be independent of the load resistance RL. So this is going to be one example of current series feedback where you are going to have a common emitter amplifier with emitter resistance RE. So derivation will comprise of the diagram explaining the and explaining what amplifier configuration it corresponds to and what parameter we have to find for this amplifier. So which component is going to act like the feedback component, and if you draw the AC equivalent circuit, how it is going to appear, and then draw the H parameter equivalent circuit, and then continue with analysis to find all the parameters starting from beta, GM, D, GMF, RI, RIF, R0, R0F, R0 dash, and R0 F dash. So once when you complete all these things, your answer gets over.